Well, welcome back. Hopefully, everybody is staying safe, staying healthy, uh, having a good day. So, today's lecture was all about the Bottle Library. And so, what we are going to be doing now is using this Bottle Library to write our own web servers. This is what we're going to be doing in class. Now, the thing to remember is that these web servers will be written in and using Python. And so this is sort of going to be occurring on the back end. So this will be run, this Python code is going to be run on the Replit servers. And this is actually part of why we're using Replit, is it provides us with the ability to be able to really see what's going on. So what I have right here, just to start us off, is a really basic bottle server. And the reason I have it this way is I'm just trying to demonstrate what we need to do in Replit to add the bottle library. So as a first step, what we have to do before we can really start working with it is we need to install this bottle library. So the way that we're going to install the bottle library is we click on this link right here that says packages, and then we have to tell it to install it. So we're going to type the name, bottle. As you can see, there's lots of different uses, lots of different add-ons for bottle. Bottle's a very popular Python library to define web servers. We just want the plain vanilla bottle library. So we click on bottle, click on this plus sign to add a package. And as we do that, you can see that automatically there's all this work going on over here in the running window. And the reason for that is right now Replit is installing the bottle library. Now the good news is we only have to do this once per REPL. So once we start our REPL, we install bottle. And once we've done that, now we're good to go. So if I go back to my files, so you can see it added these packager files. These are just files that Replit uses to tell it what libraries are there. So that way we can quit and restart. And now when I actually run the program, I'll run this one. This is, like I said, a very simple server. There are a few things that are going to happen. It's now going to go through and actually do the install. And then you can see it, when I run it, it automatically starts up. We have our normal console over here down on the lower right. And above it, it actually automatically opens up a web browser so that we can see our page. And so this is how you can tell the program is running. And note that even if I change this code right here, so rather than saying hello, I'm going to have it say goodbye, and I reload this page, make sure it's saved, saved, and I refresh the page, note that it still says hello. And this is one of the things that's different, unusual, I'm not sure what the word is, about these web servers, about the bottle library. And when we reload it, because this bottle library runs forever, it didn't actually change the program as it was running. If I want this to say goodbye, what I need to do is not only change that code, I also need to restart this bottle program. And now when I restart it, you can see it changes it changes what's here to this updated text to goodbye. If people have questions about the bottle web server or that sort of material, please ask. If you have questions about other parts of the course, please post those to Piazza. This isn't the appropriate place for that right now. I want to go over this library, these libraries. So this is a really simple bit of bottle, not particularly interesting. I'm actually going to just delete it because I don't want it in my stuff. So I have here a much more interesting version. So you can see again that I've got more code here, a lot more code here. Actually don't care. I'm going to open up the window in a new tab just so we can read it easier and debug it easier if there's any problems. And so I'm going to actually close this part of it just by dragging this up. And right away, you can see something. I'm going to clear the window just to make it easier to see. Now, if I go over here and I reload my page, so I just reloaded it, one thing you can see is that there's now this additional output in the console. And this is because when I started up my bottle server in this bottle.run code, I set debug to true. When we set debug to true, what that's going to do is it's going to output a line each time it receives a request for a page. So when I loaded this up, I made a request for the page because I'm just using the default page. It's going to send a request for this slash. It is a GET request. That's what this GET stands for. This is the URL that was requested, the route that was requested, slash. This tells you HTTP 1.1. That's the protocol that we're using. We'll talk about that more on Wednesday. And then here you can see 200. 200 tells us whether the request, a 200 request, when we see that number 200, that means the request was valid. If I try to access a page that does not exist, so I have not created a page named Bob, then what's going to happen is I'm going to get this error 404. It gives me this error page over here in the browser. And on the server side, more importantly, what you can see is there was another request made. The request was for /Bob, and I got this 404. That was the response that was given. It was an error because, of course, that page doesn't exist. So that's a sort of basic part. I'm actually going to make the code a little bit bigger so it's easier to read, hopefully, for all of you. So you can see that in this import bottle, again, I have the standard line. We always use the same, actually, I don't want that entirely there. So there's bottle.run, and then we want to say host equals, and then this is a string 0.0.0.0. And that's a way of saying respond to requests from any computer out there. We say port is assigned 8080. That's a way of saying what port it should listen to, what location it should listen to. 8080 is the standard web port. So that's just saying be a standard web server. Debug is true, so we get this debugging information. That starts up the web server. But of course, that's the way that a web server works. The web server runs on Replit, right? The browser runs on my computer or your computer, if anybody can connect to this. In order to be able to respond to requests, we need to define functions for them. And more than just defining a function for them, we need to use what's called an annotation. So an annotation is this thing that starts with @ and we have @bottle.route. That is the standard annotation for the bottle library. We're going to use this. We have to say what it should listen to. So because this function has the annotation for slash, that means any request for that default file, that slash path, will come into this function. Then we can define this function like any other. So this function, it has to have a name. The name can be anything. Probably something more meaningful than any name would be a good idea, but it's legal. And the rule is we can do any Python code we want. We can call any other functions. We can use any other modules. We can do whatever we want. We're running standard Python code. The only rule is it needs to return a string. And whatever string it returns, that's what's going to be sent to the client. So here you can see for this slash, I'm just going to return, and here I just have a hard-coded string, right? So it's an HTML/HTML. We've got a body. The body has a single paragraph saying hello. And if I go back and I request that standard page, you can see what it just says hello. And if we again use that web developer menu, turn it on, you can see that it just got that page that I sent. It's got HTML. It's adding the browser's just saying there was no header. Note that that's grayed out. It's got a body with a paragraph saying hello. And in fact, if we look at the network and reload this page in, one thing we're going to see is it thinks that it just received, let's go back to here, a page. The fact that this was a standard string does not matter. From the perspective of the computer, it just received a file like any other. It doesn't realize that this was a standard string. Whatever string we return from our function is going to be sent to the client. So that's a very simple function. We can define multiple, and in fact, we usually define multiple functions to handle different paths. So here's a path. If someone requests hertz.html, so again, I can go here, add hertz.html. And when I request that page, it's going to ask, what frequency is you? Right? It just gets the same sort of response back. It's just called, when it sees a slash, it goes here. When we request the file hertz.html, it comes here. So that's one thing that we can do, and that's relatively simple. And just a reminder, if you have questions, please feel free to ask in the live chat. So just to clarify, the day 26 is next lecture. That's why you haven't seen it yet. I haven't recorded those videos. So you haven't seen the day. You can't find the day 26 videos because they don't exist yet. So today is day 25. So one thing to remember is we need to give our functions different names, right? This is still Python. If I try to create two functions with the name AnyName, and remember I have to restart my browser each time. It's going to take a few seconds just to make sure it's going. If I request hertz.html, we get one thing. Oh. And so now, just to mess me up, it's going to work. When I was trying this out before, it didn't. Somehow it is updated the library to do that, but you should give your functions different names. So that's really simple. That's really easy. The problem is that's not particularly great, right? Like usually we don't want to just have hard-coded strings as a response. Most servers don't just have the same string that they respond with. One thing we might want to do is be able to serve up files. So here I have a file, simple HTML. You may remember this. This is exactly the same file that we were using last lecture when we talked about how we can make our pages active, how we can use JavaScript libraries. So in order to serve this up, what I need to do is I need a function to handle it. So I need to create an annotation. If I want this to come at simple.html, note that I have my path /simple.html. I have to define my function. I named it simple. And then note, I'm going to call this special function that Bottle provides, bottle.staticFile. And bottle.staticFile will read in the contents of an entire file as a string. So by calling bottle.static file. I'm going to read in that simple.html file and say, I need to use this second argument. Root is assigned dot. That just means use the standard directory. So now that file actually uses a script, right? It has a script for mycode.js. So when that happens, if I load in this file, we can see what's going to go on here. You can see the page continues to work. The page works just like before. If we look at our network, we can see that it's getting, the various files there. It got simple.html. It got when it hit that request for mycode.js, it got that. Everything is working as before. Now, actually, everything's working as before because it didn't actually load it up. It's actually using a cached version. That is interesting. There we go. So one problem I had, I had run this before. When you see things grayed out like this, it means it's using a version it has saved. Wasn't supposed to work. I was surprised that it did. You can see right now, it's able to get that simple.html file, sort of, but it's not, seems to be working. The size here is 0 bytes. The reason the size is 0 bytes is that, remember that in order to respond to an incoming request, we need to return the result. Bottle.static file reads in that file as a string, but it doesn't do anything with it. I didn't actually return anything from my function. If I want to actually have that file result, what I need to do is return the string. And again, because the web server runs the entire time, I need to restart this in order to use this updated result. So now, if I run simple.html, I make in that request. It is getting that file back. It's able then to now get the contents of the file since I'm returning it from the function, and it runs through everything properly. Just seeing if there are any questions real quick. Make sure everybody's okay with this so far. Okay. So one interesting thing you'll notice is, right, in simple.html, it's looking for a JavaScript file named mycode.js. Note that I don't, so why are super powerful computers needed for servers? Super powerful computers aren't needed for servers per se, but now realize that what we're doing at the moment is pretty trivial, right? We're not running any particularly powerful programs. And just as importantly, this system is responding to one request. I can actually see if any of you were trying to access this, I would be able to see it over here. If you think about UB Infinite, for instance, UB Infinite is handling up to 300 students, actually in the fall, up to 600 students simultaneously. That is where the powerful computer is needed, because not only is it just having to serve up 600 pages simultaneously, it's also doing a lot more processing for each one, right? So every time you log in, it's making sure you are who you say you are. It's looking up where you are in UB Infinite, what skills you finished, how many stars you have. All of that calculation takes power. So in order to handle all of those different users at the same time, it takes a lot more power. It's not necessarily that the code itself is more complex, though it can be, so much as the need to handle all those different users and everything else. Anyway, as I was saying before, you'll note that the script calls for mycode.js, and I don't have a file named mycode.js here. There are two reasons for this. One, remember that what files we have here doesn't really matter, other than, of course, we need main.py, because that's what Replit runs initially. Beyond that, it doesn't matter what files are named. What matters is in our web server code, what annotations we have defined. And so we've talked about hertz.html, simple.html. You can see here, I've got a function that's annotated to respond to mycode.js. So what that means is that when there's a request for mycode.js, it's going to come into this function. Now, what's different about this function is that you can see it's going to call bottle.staticFile to return that file. But of course, the file name it's reading in, the file name that I actually defined, is frontend.js. And so it's going to call to read in frontend.js with a root of dot. Now, the trick is that my computer, that's on the server. So the server says, hey, respond with this file frontend.js. It can read that in, no problem. It returns that result, so it can return its contents, no problem. But note that from my computer's perspective, the file name is mycode.js. The fact that we pulled this little switch, the fact that when we do this, the file that we respond with does not have the same name as what it's stored on the server, doesn't matter. My computer, my browser, this right here, has no clue what's going on in the server. It only knows what responses it's receiving. At the same time, the server isn't really paying attention to what files are called, right? It just knows, it has an IQ of 0. It knows when a request for /mycode.js comes in to run this function. The fact that we're responding with a different file name, it doesn't realize that anymore. By the time it starts running the function, it doesn't remember how it got there. So there are times when we might want to rename files or redo these sorts of ideas because it's just easier. So sometimes we'll put things into separate folders, or we want to change around files, but we don't. And so we want to change the names that we use them with, but we don't want to make it difficult for the end user. There are reasons why you might want to do this. The big thing is to remember that this route, the annotation, the path that we define, that's what the client is going to see. The code inside here is what the server is working with. We can, and often do, have them match, but we don't have to. So there are other things that we can do that are a little bit fancier. So one thing we can do, for instance, is suppose I've got this file named.html. And what I want to do is talk about the different sections of, say, 115. So now, for this semester, there are 2 sections of 115. I'd like to be able to display a page for each of them, but I'd really like to display more or less the same page for each of them, even though the section number will be different. Possibly the professor would be different. In this case, not so much. This is one thing that the Bottle server gets us. If you look, it has section, and then I have in double braces, SEC. And I have the professor is, and in double braces, name. If I go over here and load up, I think the name of that file was name.html. If I try to load up name.html, I get a 404 error. The reason I'm getting a 404 error is because the server doesn't have a function whose annotation says to handle name.html. That's not what the file is for. On the other hand, if we look at, say I want to look up section A, it's going to say section A, the professor is Hertz. If I want to look up section B, it will now say section B, the professor is the best. It's still me. And right, I have two different pages, each for a different section, but I only have one HTML file. And what I am using is what's called a template. So here you can see I have two different functions, later section and earlier section. Earlier section has the path sec A. So when I make that request for sec.a.html, it's going to run this. And again, I need to return a string, but it's now not going to call bottle.static file. Bottle.static file returns a file given the contents it has exactly. Bottle.template, on the other hand, takes in two arguments. The first one is the name of our HTML template, name.html in this case. That's what I named that file. The second argument has to be a dictionary. The keys of this dictionary are sort of variables we had in our original HTML file. The things that we have inside these double braces. And the value is what it should replace it with. So this is saying when we call for section, this file SECA, we should replace SEC with a capital A and name with Hertz. And so what happens is when I make that request for that file, it's going to give me whatever is in name.html, but after making those replacements. And note, it's invisible to my browser. From my browser's perspective, it works just the same. For section B, it's going to do the basic same idea, but you can see here, I'm just using a dictionary as a variable. Section is B, name is the best. We can make it whatever we want. We can make these changes as much as we want. And this is, again, someone was asking why are super powerful computers needed for servers. One of the things that most websites will do as a very simple first step is to create these templates so that way when you log in, it says something about you. When I log in, it can replace those blanks with something about me. It can go through. The other thing that we can do is actually do a little bit more with these routes. So here I have @bottle.route, and note that I have /sec, but then inside of the greater than and less than sign, I say sec, and then .html. And now this function, unlike all the previous functions, has a parameter that has to match that. What this allows me to do is have one function handle lots of different requests. So anytime there's a request for a section that isn't A or B, it's going to be handled here. And SEC will be assigned to whatever got passed in. So in that case, what I want to do is I'll use my template. I'll use whatever section they wanted to see. But then for the name of the instructor, I'll just put unknown because it doesn't really exist. And so this means now I can create if I want to look up a section C, it can respond perfectly well. It just updates this section to whatever I passed in and says the professor is unknown. If I want a section EE, Again, it just fills everything in. It takes whatever comes in after the SEC and match it and says that is what I'm going to use as my parameter to this function. And I can make all sorts of different changes. And so this is actually one of the nice things about the Bottle library. We are going to be able to serve up any page we want. We can write a fairly, this is not the most exciting of web servers, I admit, but it is a web server. We can respond with static pages. We can respond with other HTML pages. We can actually create templated pages and allow things to change. And if our pages use JavaScript, if we have active pages, we can still make active pages, right? So if I go back to that simple.html, we can, as before, have those active pages. So everybody okay with this? Any questions about how the Bottle server works, how these web servers work? So this is something you're going to need for lab activities, potentially lab exams. The project, eventually, you'll be writing a complete web app. So you will be writing a Bottle backend as well as other front-end code. And we will be doing more with this over the next couple weeks. If there are no other questions, then thank you all for listening in, for watching this live stream. I'm happy to answer. If you have more questions after this, please feel free to post them into Piazza. Ask TAs during office hours. Ask me during office hours. And I will talk to you all later. Thank you very much. Stay healthy, stay safe, try to have some fun. Bye.